All right, so that up to now, all are almost related to CDMA or spread spectrum. Even some concept, for example, for the adjacent channel interference, perhaps it won't be necessary to be related to CDMA, but currently we can think or talk about the spread spectrum, and I'm talking about the CDMA system. And next one, we can have the new system, and this new system actually not the CDMA based system. Actually, it's OFDM system. It's FDMA system, but right now we have the specific one we call OFDM. And OFDM, similar to FDMA, we divide. Currently, maybe something wrong. Currently, we have the whole band, and we try to divide the whole band into multiple sub-channels. All right, so here it says, okay, you can have the original channel, and how to have the multiple sub-channels. If we can have the proper spacing, and the proper spacing can be put into the compact manner, and then we can accommodate more sub-channels here. This kind of more sub-channels. So we still rely on orthogonality. And orthogonality, if we have a non-overlap channel, of course, we can have the property of orthogonality. But how about, okay, we have a multiple, and can we still have the orthogonality? The answer is yes. If we can have the proper spacing, of course, the way to have the proper spacing, you can refer to the task book. Then we can get to know, okay, follow that one. Then we can have the compact manner to have the multiple sub-channels. Or here, we can have a single carrier if we have the way. Then this way, each carrier won't interfere each other. Still, we can maintain the property of orthogonality. Therefore, if we can achieve this, and then we can have the beta efficiency about the spectrum utilization, and so that we can have more channels for OFDM. Well, if so, we can have more channel for sure. And because of that, more channel there, and then we can have the multiple channels. So here, we can have this way. Previously, it says, okay, we can have a single channel becomes multiple channel. So we want to carry high-speed data. We want to carry high-speed data, only one carrier. Is it enough? No, not enough. So we can use the previous one to have the compact manner to have the multiple streams. For example, previously we have a single carrier, maybe each carrier to represent the low speed bit stream. And right now we have a multiple, so 1, 2, 3 to n, and then count more low speed bit stream, then we can carry high speed data. All right, so how to carry this? Actually, we try to have the serial to parallel conversion. The serial to parallel conversion, of course, okay, we have the separation 1, 2 to n information. And so that, okay, the first batch, second batch, the nth batch, and each can be carried through the low speed stream. And then we can reach the destination. All right, so if we want to have the high bit data, actually we rely on the conversion from serial to parallel, and even single carrier denote the low speed, that's fine. And here we have a multiple low speed carrier, but multiple can carry high speed data, so that we can have the high speed data stream input to at least the 2 blocks. And if we have this, then for OFDM employ inverse discrete Fourier transform. Maybe you have a question, why inverse first and then discrete Fourier transform? Yeah, maybe if you have an operation like this and exchange similar to, oh, okay, at least we have this one. But actually, for some reason, I don't check that one, but at least this is the employee module to have inverse discrete Fourier transform first. And then possibly we need to have the separation. So we have the gap interval insertion so that we have the proper separation. And so that we can have the signal to be transmitted to the air. And here we call it's the transmission of OFDM signal. Well, through the air, and then we can receive the signal. So we can call, okay, receive the OFDM signal. Receive it, so we need to have the inverse operations. So, the reverse operation including, previously we have gap interval insertion. So we need to remove it. So gap interval removal corresponding to the insertion. And previously we have IDFT. So right now we have a DFT. So at least we have the reverse operation. And right now we have a multiple carrier, same carrier 1 to n. But right now we need to have, once we can get the B string, then we need to have the n string converted to a single string. And once we can convert it from multiple string to a single string, again, we have the high-speed data string. It doesn't mean we recover, but at least this is a way to take them back. The way through the separation to have the parallel low speed bit streams. And right now we have a parallel string, and once we have old information, then we can convert them into a single stream, and the single stream, of course, represent the original high-speed data stream. And this is the blocks. Here we call it's demodulation and modulation. For someone like you don't care about the detailed operation, okay, you can treat this is operation before transmission, and this is an operation after receiving the signal, and so that we have the corresponding processing. But the real operation is formally called, this is a modulation operation, and this is a demodulation steps at the OFDM receiver. All right, this is the two sides operation. All right, then you have 2 minutes to check this page again. So go and check it. If any question, you can let me know. So before I continue, actually, let me mention one thing, important thing. Maybe 2 weeks later, we will have 2 weeks later. Next week, we still have a discussion about chapter 8. And 2 weeks later, it should be talking about case study. And then we will have an exam. As I remember, maybe it should be 3 weeks later, we will have an exam. So all you need to review chapter 1 to chapter 8, and including supplement. So this is a reminder to you. We will soon to have the exam. And about the exam, we may have some formula. So I allow you to have 1 A4 page and 2 sides to have the formula, but not the solution to the possible problem. No solution, but the formula. And so that I allow you to have the closed book style for half of the time. And for the remaining time, then I allow you to look up the A4 page. Of course, if you have the A4 page, it will be better. And also, you can have the calculator, bring the calculator to the classroom, and you can have the calculation using the calculator for sure. As I remember, maybe 3 weeks later, we will have an exam, right? So you can check it. As I remember, it should be 3 weeks later. So be well prepared, and so that you can answer properly. But notice that even you have the way to look up the formula, you need to prepare. And also for half of the time, actually the initial half of the time, you need to answer using the closed book style. The second one, formally we can call open book, but it is not book, it's just the A4 page, 2 sides. All right. As for how to prepare the formula, you can use your own way to have the formula. All right. So we're well soon to have the exam, so be well prepared. It's just a reminder to you, so you need to review. And meanwhile, of course, you need to know, okay, if you have the textbook, it will be better. If you don't have it, I'm not sure, but at least I will take some result from the textbook, because of course, for me, I have the textbook, but for you, how to have the content, you need to rethink about this. All right, maybe, okay, you still can find the hyperlink to download some PDF file containing the content of the textbook, that's fine. If no, and then what's your strategy to prepare the exam? If you simply rely on the PPT slides, maybe not enough. All right. And of course, I will try to provide you the slides video, and so that you can focus on some if you want to review. Of course, normally we have the stream video. If you never mind that one, you can check the stream video directly. But I will try to directly have the slides video, so that you may have the video clips ranging from 5 minutes to 15 minutes, possibly. So that one maybe I will provide you later, because of some matters I cannot directly have maybe on time. But I will directly have before the exam, so that you can have the video to review in time. All right, so this is the reminder, and also some possible video clips, the shorter video clips for you later. All right, so this is OFDM. Let me move on to the next one.